So that's a similar one we have here in our shot with a slice. So these ones are schematic diagrams showing us how the video we have watched, how the process is, how the shearer moves one step at a time to scoop the material and whatnot. So you could have a look at it and read on your own. So we said, I explained most of these techniques when I was explaining the supported, unsupported, and then the block caving. So the block caving itself is another type of mining method where you design or do all the necessary development. And usually you try as much as possible to have a very competent surrounding rock, but then your deposit is quite weak. And so you develop it, and then the deposit you want to target must also be quite steeply dipping, such that when it is breaking on its own to flow by gravity, it can flow very well. And the deposit must be uniform, quite uniform, such that you would have the ore flowing through the chutes you are going to put in place for drawing the ore at the various points that you are going to put the funnel shapes. So let me see if I think I have another video for that one too, for us to look at.
Block caving is a large-scale mining method that allows for huge volumes of rock to be extracted efficiently. However, the development time before production starts is longer compared to other mining methods. By drawing rock from the extraction level in the lower part of the mine, a gap is created. Absence of support for the overlying rock mass, together with rock stress and gravity, will cause the rock mass to cave. This minimizes drilling and blasting of ore, but required the ore body to be large enough and the rock conditions to be favorable for natural breakage. To draw the first pieces of rock, to create this gap, the rock mass in the lower part of the ore body needs to be broken down into
low-grade ore bodies, such as the deposits at Northparkes. The ore to be extracted is in the shape of a large irregular block, which can be up to 500 meters in height and several hundred meters in length. The development stage at Northparkes began by gaining access to the ore body with a gently sloping tunnel called the decline and a vertical shaft. The shaft is used to carry mined ore to the surface. The decline is used to transport people and equipment into the mine and to provide fresh air to the mine. The decline and other drives are created by drilling and blasting using a machine called a jumbo. All tunnels are supported by rock bolts and shotcrete to ensure they are safe. After the axis is created, a series of parallel extraction drives are developed from one side of the ore body to the other. Between the extraction drives, drawbells are developed. The undercut level is developed at the same time as the extraction drives. Rings of drill holes are charged and fired from one side of the ore body to the other. The drawbells are drilled and blasted to become a series of funnels that will feed the broken ore to a draw point. This process breaks a layer of rock across the bottom of the block of ore and leaves a large unsupported area which starts fracturing and caving under its own weight. The ore body starts to cave once the undercut is complete and ore is removed from the drawbells, creating a void. Once the development is complete and the ore body has been undercut, the mining process is relatively simple, with continual fracturing and breaking of the rocks to smaller rocks for extraction without any further blasting. Special low-profile load-haul dump vehicles collect the broken ore from the draw points and dump it in the underground crusher. The crusher breaks it down into smaller pieces which are then loaded onto a conveyor, transported to an ore skip and hoisted via the vertical shaft to the surface to be processed at the mill. The block cave ultimately breaks through to the surface and a subsidence zone is formed. Over time, and as more ore is extracted from the cave below, the subsidence zone deepens and widens. One of the innovations at Northparkes is automated loading, which was introduced in 2011. Instead of having miners deep under the ground driving the loaders, they work from the surface, controlling the loaders by remote control, making it safer for the miners.
All right. So that was a demonstration of how the block caving technique is done. After you have done all your developments, kept in your funnels and all that, blast the rings, and you trigger your first blast. Because the deposit is quite weak, it begins to cave in into the various funnels or the collection points you have created. And there you have, and then the major disadvantage of this method had been the subsidence that it creates at the surface, because you are taking the whole of the block at a go. It begins to create some kind of a subsidence at the surface if someone is more or less on top of the land. So that is one of the disadvantages of this method. Otherwise, it is seen as one of the most productive underground mining techniques, because this one, you are able to get huge production out of it. A lot of expense is reduced. Once you do your drilling and blasting from the first stage, there's no longer any other activity or development you are going to do going forward until you have extracted the whole deposit. Then let's see, there's another one called the sub-level caving, which is also, and I think that one was, there's a mine in Ghana that used to use that method. Is it Chirano? So Chirano also used to implement the sub-level caving technique. So this one too, it behaves like the usual room and pillar techniques that we have been using, but this time around you create levels, and after you have finished with the levels, you go ahead and create levels in between the main levels you have left, and then you begin to work, drill and blast the material at a particular level. Then you go to the next level and receive the material there. So it begins to cave from that point where you did the blasting to the next level. So you go down there and pick it up. So in this type of technique, you work from the top to the bottom. So you're always at the top level. You do your drilling and other stuff. Then you move to the down level and go and extract the material from there. And that is the sub-level stoping, a sub-level caving. And we also have sub-level stoping. Sub-level stoping is where you create the sub-level, but this time around, you don't allow the ore to break by itself for you to go to the next level and collect it. So there's nothing like caving in this technique. However, you have the whole place intact, just like it would be in a normal room. You are there and various people working at various levels of the stopping process. So you create the sub levels just to allow for increased production. So you have one person in a particular level working, or a crew in a level working, and you have another crew in another level working. They can all work concurrently, and then you increase your production. So let me see if I have another demonstrative video here for. Okay, what I have here is sub-level caving.
Sub-level caving is a large-scale mining method suitable for large ore bodies with a steep dip and a rock mass where the host rock in the hanging wall will fracture under controlled conditions. Therefore, the infrastructure is always placed on the footwall side. Mining starts at the top of the ore body and progresses downwards in a safe sequence. It is a productive mining method where all of the ore is fragmented by blasting, and the host rock in the hanging wall of the ore body caves. Once the production drifts have been excavated and reinforced, the opening raise and long hole drilling in ring patterns are completed. Minimizing hole deviation when drilling is crucial, as it will affect the fragmentation of the blasted ore and therefore also affect the flow of the caving rock mass. Rock is loaded from the cave front after each blasted ring. In order to control dilution of waste rock in the cave, loading a predetermined extraction percentage of rock is done. Or if there is a significant difference in density between ore and waste rock, bucket weighing can be utilized for dilution control. When loading from the cave front, it is important for the productivity to keep the roads maintained in a good condition. Dumping the ore into ore passes connected to the haulage level is an efficient way of transporting rock from the production points to the crusher. Each sublevel features a systematic layout with drifts across the ore body. Activities in the parallel production drifts are performed simultaneously in order to maintain a good process in the mine. Due to caving of waste rock into the blasted ore, a certain degree of ore loss and waste rock dilution comes with the method. Caving will sooner or later also cause subsidence on the surface. Sublevel caving is a productive large-scale mining method, a good process in the mine. Due to caving of waste rock into the blasted ore, a certain degree of ore loss and waste rock dilution comes with the method. Caving will sooner or later also cause subsidence on the surface. Sublevel caving is a productive large-scale mining method that enables safe and efficient use of mining equipment. With to the blasted ore, a certain degree of ore loss and waste rock dilution comes with the method. Caving will sooner or later also cause subsidence on the surface. Sublevel caving is a productive large-scale mining method that enables safe and efficient use of mining equipment. With good mine planning, there are also great opportunities for automation.
All right, so that is it for sub-level caving, the caving techniques we have discussed so far. So with this particular technique too, another disadvantage is it is highly mechanized. You can mechanize this technique, but then the disadvantage is that you should be able to know the difference between your ore using maybe density or any technique in the mineral process that can help you identify your waste and then your ore, such that when you are mining or when you do the blasting and you are collecting the deposit, because there's going to be caving from the hanging wall side that will exert pressure or allow the ore you have blasted to be able to flow to the collection phase for you to collect your ore. And so if you don't know that measurement or that differences between the deposit and then the waste rock, you would always encounter a reasonable amount of dilution. All right, so let's talk about unit operations of mining. We discussed this in the surface mine, but then in underground too, what are some of the basic things we do there? So when we are dealing with underground operations, we talk about drilling, we will charge, we will blast, and bog, which is collecting the material we have blasted. Then we provide ground support if necessary. So that is why we said the various techniques we have are that you have supported, unsupported. So most of the time, to be on the safer side, even if we think the ground is competent enough, we still go ahead and put some wire mesh on the surface such that we don't have any material tripping from the roof to hurt us. And so we put in some wire mesh and then do some grout and spray some cemented material on top of the roof to make sure we are still 100% safe to operate or to do our activities. That is what goes on there. Then we have transporting of the material. But then one last thing which is not mentioned here is how we manage water underground, which is also one of the auxiliary operations we do in mining activities. We have auxiliary operations. These are activities we do underground or in mining in general, which do not constitute production, but then they are very essential to our output. For example, managing water underground, that is using the pump system to manage water underground or pump water in a mine. And then ventilation. When you are operating underground, you don't usually have air flowing through the mine naturally as it would on the surface. And so you have to find a way to force air to operators or crew working underground. So it's also another activity you have to ensure. If there is no air there, you are going to kill your workers. And so most of the time, we have to have an entry point where there's air going in and then an exit point where bad air is taken out of the mine. And so this also adds up to your cost when you are operating underground. So you realize that the video we watched on block caving, they said that they are not using man to do the hauling activities. Instead of having human beings down there to do the hauling activities and the transportation of the ore, they are rather using remote or driverless machines. So the operator will only sit somewhere in the mine plant settings or in a particular place and use devices, joysticks and whatnot to operate the machines and then get the ore out. So in this approach, then you don't need oxygen there. But maybe you may have the setup, assuming there's a mess up somewhere where human being has to go in there and resolve that. So those are some of the activities we undertake when we are dealing with. So that is what we have here. So it says you do drilling, you do blasting, and then after blasting, there is the need to have supporting ventilation and pumping. These are auxiliary activities that has to go on before loading and hauling can take place. Then after that, you transport. So with these ventilation activities we are discussing, if you are interested in doing your research work or your activities in ventilation, just like we are discussing, providing air, you want to feel important. Now, without your air, we can't work underground. You want to go into it more. You can register for the course. Mine engineering, environmental engineering in mining. Yes, that's a course that is yet to be taken. I don't know if you have already taken that. So if you're interested in taking a project in any of these ventilation things we are talking about, it will be ideal you register for that course and get a better understanding.
I will do that.
Yes, or a detailed understanding of that particular lesson. Then it will give you more insight as to what you should look out for if you want to take any project in that area. It's very interesting. Yeah. Then we have those of us who also want to do what's the name, drilling, work in drilling and other stuff. You also have to register for mine explosives and mechanization, mine machinery and mechanization. It's also a course there, so you can go into details. I told you my course is a teaser. I want to tease you, let you understand that yes, mining is joy. So then we have the transporting, loading, hauling, and then transporting. That one too, materials handling. It's a course you can take if you are interested in seeing how we manage our truck fleets, excavators, matching excavator to trucks, and then how we manage material in general in the mine. We go for materials handling and you'll be fine. All right, so I think with this, our program has come to an end. We have finished with introduction to mining engineering.